Move on to number 10. And here again we get into the language a little bit of math. And when we think about factors, factors are, for example, 3 times 4 is 12. 3 and 4 are factors of 12. 12 is a product in that multiplication. So in this case here, let's read each of the problems. It says 6 is a factor of 19. Is there any number, any whole number times 6 that will give me 19? No, in fact, 19 is a prime number, meaning that it is not divisible by anything but 1 or 19. It's not divisible by 2 because it's not an even number. It's not divisible by 3 or 4. It's not in any of those times tables. Letter B says 40 is not divisible by 8. In fact, 40 is divisible by 8. You could divide 8 into 40 and get 5 as a quotient. So that's not true. The C says 2 is a factor of 29. Now 29 is an odd number, so there's no way that 2 could be a factor of it. Letter D says 40 is a factor of 8. That's not true. 8 is a factor of 40. In other words, 8 times 5 is 40. 40 is the product, but not the factor. The last one, letter E, is the only one that's true. 40 is divisible by 5. In fact, when you think about your 5 times table, the 5 times table would be any numbers that end in 5 or 0. So 40 is divisible by 5. Number 11. Read the problem along with me very slowly. It says, if 2 is a prime factor of 22. Now let's think about that for a second before we even read the second part of the question. Is 2 a prime factor of 22? It is a factor of 22 because 22 is an even number. In other words, you could divide 22 by 2 and get a whole number answer. Is it a prime factor? In other words, is 2 a prime number? Yes, it is. A prime number is a number that can only be divided by itself or by 1. So now the second part of that question says, what is the quotient? In other words, what is the answer of 2 into 22, or 22 divided by 2? And obviously, you can use your calculator with this, but hopefully you'll know your times tables well enough to know 2 times 11 is 22. In number 12, we talk about least common multiples of a number. So in other words, we want to find a number that is the least common multiple of the number below. And the two numbers are 35 and 10. So if I go by my 10 times table, my 10 times table is going to be 10 times 1 is 10, 10 times 2 is 20, 10 times 3 is 30, and so on. It's going to keep going up by tens. The 35 times table, which I know you probably don't have it memorized, but just follow along with me for a second. 35 times 1 is 35. 35 times 2 is 70. Whoa, hold on a second now. Let's stop right there. There's your least common multiple for those two numbers, 70. Now how to solve that? Actually, if you look at the table that I set up on the right hand side of the screen, I wrote the number 10. The prime factors of 10 are 2 times 5. Then I wrote the number 35. The prime factors of 35 are 5 times 7. Since both terms have a 5, we could actually cross off one of the 5s since they have a 5 to share. Then we take the other three numbers, the 2 times 5 times 7, and that gives us the answer of the least common multiple. You've reviewed this in the past if you took Math 98 or Math 99, and I'll be glad to go over it with you further if you need help with that. Using the divisibility rules in number 13 to help determine prime factors of the number below. The number is 93. So First of all, at the end of this slideshow, there's a brief presentation about finding prime factors. In other words, divisibility rules for 2 and for 3. I already talked about the divisibility rules for 5. For 5 times table, the numbers end in 5 or 0. A divisibility rule for 2, basically they're even numbers. So 93 is not an even number, so 2 does not divide 93. But there is a concept called the checksum. Now this is something I learned way back in grade school, and I hope to get the point across to you either here on number 13 or at the end of the slideshow when we talk about the divisibility rules for 3. Basically, look at the number 93. 9 and 3. Let's add those two numbers. 9 plus 3 equals 12. Now, is 12 divisible by 3? Yes, it is. So in fact, if I use this idea, the checksum, 9 plus 3 equals 12, and that number is divisible by 3, then that means that 93 is also divisible by 3. So even though 93 would look like a prime number to you, just on the surface, you have to look at the checksum and realize, hold on a second, I could divide 93 by 3 and using the calculator get the answer 31. Now 31 is a prime number. In other words, there is no whole number except for 1 or 31 that will go into it evenly. So then your prime factors for 93 are 3 times 31. Notice that we use the dot in the middle. That's another way of expressing multiplication, is with that dot in the middle, 3 times 31. Let's go back to it. 4, 5, 6, 7, 8, 9, 10, 11, 12. I end up at -2 as the answer. Okay, so it's using the number line to solve this type of problem. Now you could use the TI calculator, the graphing calculator, and what you would do is you would push the key. It's right below the 3 number on the calculator. It has a negative sign, but in parentheses. That means negative number. The subtraction sign is with the other operations. You have addition, you have subtraction, multiplication, and division. But when you want to use a negative sign, you would use the negative sign in parenthesis. So you'd push negative sign 14 plus 12, and that would give you the answer 2. Or rather, -2. Number 15. Here's a golf example, and I sometimes wonder if I should use this because not too many folks really do understand the game of golf. But in golf, basically, if you play average, if you play the average for the course, that means you're playing 0 par. So think about 0 as being okay. The more negative a number is, the better off you are. The more you're under par, the better off you are. The more you're over par, like my golf game, the worse off you are. So it says here, Megan shot rounds of golf. The first round she shot was 4 over par, so I wrote it +4. The next one was 1 under. I wrote it -1. Then 2 under, -2. Then 3 under, -3. Then what I did was stepwise, I went from 4 minus 1, which is 3, 3 minus 2, which is 1, and then 1 minus 3, which gave me a final answer of -2. And number 16, this is a special one where, you look at this problem, you say 10 minus a -9. Well, hold on a second. 10 minus 9 would be easy. If I had 10 pennies and I took 9 away, it would leave me with 1. But in this case here, you have 10 minus a -9. Now, I'm just going to tell you, you need to add those. All right? When you see this type of problem, it looks ugly. And the best way to resolve it is to just change the problem to 10 plus 9. I could go into a lot of detail on this, but it would take a while, and it's really not that important. If you don't believe it, you could go to the graphing calculator again. I talked to you about that button that's right underneath the 3. So how I would do this on the graphing calculator is I would enter 10. Then I would hit the subtraction sign because that's what the problem says, subtract. Then I would hit the sign that has the minus in parenthesis right below the 3 button, and then hit 9. So then the problem on the screen would read 10 minus 9. When you hit enter on the calculator, it will solve it as 10 plus 9, or 19 would be the answer.